So this lesson is on binary ionic compounds. Binary, what does the prefix bi stand for? Josh?
Two.
Two, stands for two. So, two elements, and what does ionic stand for? Or what is an ionic bond? You guys just did those videos. What's an ionic bond? Nobody remembers? Josh? A metal and a nonmetal. So we have two elements. One is a metal, one is a nonmetal. The metals always have what charge? Positive, negative? Look on your periodic table and look at your metals. What are the charges on your metals? Positive. They have a positive charge, and how about your nonmetals? They have a negative charge, so we're mixing a positive with a negative. All right, all compounds, when we're mixing them, they need to have a neutral charge when they come together. So let's go through a couple examples of some binary ionic compounds. All right, the first example, we have sodium chloride. To write formulas, we're going to make it like a math problem. Write the name of the first element. So sodium is Na. What is the charge on sodium? What's that? Positive 1, because it's found in group 1A. And we're adding it to chlorine, which is Cl, and the charge on chlorine is -1. Are my charges balanced?
Yes.
Yes, they are. So we bring them together with a ratio of 1 sodium to 1 chlorine. Make sure you are writing it like this on the quiz that you guys had. Some of you were not doing it this way. All right, calcium chloride. Calcium, the symbol is Ca. Calcium is found in group 2A. So since it's found in the group with the atomic number 20, it has a positive 2 charge. Fluorine is found in group 7A. Symbol F has a -1 charge. My charges are not balanced. So what do I need to do to get my charges balanced? Kayla? I need another fluorine. As an element, it's fluorine. When you list it second in a compound, you add the IDE. So you need 2 fluorines to balance out the positive 2 calcium. All right, aluminum oxide. Aluminum is Al. Aluminum has, it's found in group 3A, so it has a positive 3 charge. I am adding it to oxide is oxygen, which is O, has a -2 charge because it's found in group 6A. And when I bring them together, I need to balance their charges. So how do I do that? Molly?
Bring in 1 more aluminum and 2 more oxygen.
So 2 aluminum and 3 total oxygen. Make sure you guys use the subscripts correctly. All right, now the reverse. Now we're going to write the compounds, the name of the compound, given the formula. Okay, writing the names. What would a chemist name the compound CuCl? Now, we're going to start talking about these elements that are located in the middle section, which are our transition metals, so all of these metals in here. And if you look on my periodic table, you'll see that a lot of them, like vanadium, has 4 different charges listed. Okay, so to identify which charge they are, we're going to use a Roman numeral. I put that in your notes. Here's a list of some of the most common that use the Roman numeral. The first example I have, copper chlorine, is going to need a Roman numeral. So how we decide that, let's go ahead and write the formula copper. Oops, the name copper. I want you to put parentheses. In that parentheses, we're going to have to put a Roman numeral. The Roman numeral is going to tell us the charge or the oxidation number of that particular atom. To decide what the oxidation number is, we have to look at the second element listed. So we have chlorine, and if it is a single element, we take off the ending, so the ending is INE, and we add an IDE. So instead of chlorine, we're going to say chloride. And go to the periodic table and find chlorine. chlorine is found in group 7A, has a -1 charge. Okay, chlorine has a -1 charge. So to balance it out, copper has to have a +1 charge. So I put a Roman numeral 1 in the parentheses. So you have to make sure that you identify it as copper 1 chloride. All right, the second example, what is the name of CuO? Okay, again, we have copper. I'm going to put parentheses because I need to show which one I'm talking about. It's in column 11, so it's in that transition metal section. O, the element is oxygen, however, I need to say oxide. I take off the ending and add IDE. Caitlin? Okay, and to find the Roman numeral, we have to look at oxygen. Oxygen is found in group 6A. It has a -2 charge. So to balance it out, copper needs to be a +2. So we put the Roman numeral 2 inside parentheses. Again, we only need Roman numerals is when we are dealing with our transition metals in that middle section. All right, what is the name of AlCl3? Okay, Al, what element is that? Aluminum. So the first element, we just list the name, aluminum. Does it need a Roman numeral? Is aluminum found in that middle section? No, it's not, so no Roman numeral needed here. The second element is Cl, which is chlorine, and since it's listed second, I would say chloride. So aluminum chloride. Not too bad, right? All right. A little bit more. So we were dealing with binary ionic compounds dealing with 2 elements. Now we're going to add a couple more. If we have more than 1 element or more than 2 elements listed in a compound, usually we have what's called a polyatomic ion, poly meaning many, attached to one of the elements to make it a compound. Now, polyatomic ion, they are positively or negatively charged covalently bonded group of atoms. So if you look at your list, I gave you guys a list. I also emailed it to you. You can see that it's not just a single element listed on there. In the +1 column, we have NH4, which is ammonium. It is the only +1 polyatomic ion that we will deal with. All the rest of them have a negative charge. So you can see the second group, they all have a -1 charge. The third group down, starting with carbonate, they all have a -2 charge. And then down to -3 phosphate, that group all has a -3 charge. And as a group, so if I look up at ammonium, the nitrogen and the 4 hydrogen together come together in a covalent bond and have a +1 charge. So as a group, they have that charge. So let's name some compounds dealing with those polyatomic ions. Remember that with a ionic bond, we always have the positive ion listed first and then the negative ion. Okay, so if we have a polyatomic ion, it's going to be ammonium, NH4. And on this first example, it's not ammonium, so I know that I'm going to use the element that's on the periodic table that has the symbol Li, which is lithium. And then NO3 is covalently bonded together. I can tell because this isn't just 2 elements anymore, it has 3, so NO3 has to be on my list. So I'm going to go to that list and find NO3. It's about halfway down the page. NO3 is nitrate. So lithium nitrate would be the name of that compound. All right, the next compound, the symbol K, what does K stand for? Kayla? Potassium. And then I have SO4. Again, because we're dealing with more than 2 elements, we're not going to write potassium, sulfur, oxygen. SO4 is grouped together. So SO4 is listed about 2/3 of the way down the page with a -2 charge. It is sulfate. A lot of times when we're dealing with polyatomic ions, you'll see them put into parentheses, especially if you have multiple of them. So looking at my next example, I have NH4 and then I have 2 of them. NH4 is on my list as ammonium. We list the positive charge first. ammonium. And then SO4 is also on my list. SO4 we just dealt with. Previous problem is sulfate. So ammonium sulfate would be the name of that one. All right, the last example, my first element, Cu, is copper. Now, copper, if you remember, is one of the elements found in our transition section. So it needs a Roman numeral. I'm going to leave a blank there for the Roman numeral. ClO4, I'm going to find that on my list. ClO4 perchlorate. And looking at the compound form of it, I have two of them. The number on the outside of the parentheses tells me how many I have. Now, perchlorate by itself has a -1 charge. However, I have two of them. So since I have two, what is the total charge of the perchlorate? A -2. Does everybody understand that? Each one is -1. I have two of them, so that makes a -2 charge. I go over to copper to figure out what I need to put in. There's only one of them, so that one copper has to have a +2 charge to balance out the -2 that the perchlorate has. So the Roman numeral 2 goes in there. All right, now naming these compounds. Aluminum hydroxide. Aluminum, do we find on the periodic table? Yep, aluminum. What is the charge? +3. Aluminum's right here. Hopefully you guys are starting to become a little bit more familiar where things are located. +3. Hydroxide, it does end in ID, however, it's the one on the polyatomic ion list that, actually there's two, hydroxide and peroxide that are on that list. Hydroxide is OH with a -1 charge. So are my charges balanced? No, they're not. Figure out a way to get them balanced. Well, if we have a +3, I need to have a -3. So that means I need to have 3 of the hydroxides. So Al, in parentheses, OH, and then on the outside of parentheses, we need to put the 3. You do not put the 3 with each individual element because when we are actually doing the compound, we need to show that it's 3 OHs and not one of this compound, okay, which is different. All right, the next example, chromium-3 sulfate. Chromium is Cr. The Roman numeral tells me that the charge is +3. Sulfate is found on that list. Sulfate is SO4 with a -2 charge. Looking at my charges, they are not balanced. We've seen one like this before. I think aluminum oxide we had before. To balance the charges, what do I need to do? Josh?
Add a chromium and 2 sulfate.
Another chromium, so I'm going to have 2. And a total of how many sulfates? 3 of them. So again, when you're having multiple of these polyatomic ions, you need to make sure that you put it in parentheses and then on the outside, put how many. All right. Last one on here, sodium is Na. Sodium has a +1 charge. Chlorate is found on my list. Chlorate has ClO3. Make sure you have the right one with a -1 charge. Charges balanced? Yes, they are. So I'm going to write it just like it is. I do not need parentheses because I only have 1. However, if you add parentheses in there, that's okay. Just make sure you don't put a number on the outside of the parentheses. All right? Okay, go to the worksheet. I'm going to do a few examples for you, and then you're going to have some for homework. All right, back to naming. I'm going to do 1 and 2 with you. So naming, we have NH4Cl. NH4 is the only one on the list that has a positive charge. So NH4 is ammonium. And then Cl is chlorine, but since it's listed second, is chloride. Number 2, Fe stands for, Kayla, iron. And make sure we're paying attention to where these are located on the periodic table, because iron's right here, which means what do I need? I need a Roman numeral to tell me which iron I'm talking about. So I'm going to put parentheses there. NO3. NO3 is grouped together, so I'm going to look on my list. NO3 is nitrate. Alright, so to decide what Roman numeral goes in there, I need to look at the charge for nitrate. Nitrate is a -1 charge. However, on the outside of parentheses, it's showing me that there are 3 of them. So if you have 3 -1 charges, that's a total of -3. So that means that iron has to have a total of +3, and there's only one of them, so that 1 holds the +3 charge. All right, let's go down here to number 11 and 12. Okay, chromium is Cr. What Roman numeral is that? 6. That is 6. Bi is 6. Id is 4. That's 6. Phosphate. It does not end in IDE, so that means it's on the list. Phosphate is down with the -3 charge. PO4, -3. My charges are not balanced. So to get them balanced, I need to have a -6 charge, which means I need to bring in another phosphate. So on the outside of my parentheses, I'm going to put a 2. All right, number 12. Vanadium. What's that Roman numeral? That's a 4. So vanadium has a +4 charge. I'm adding it to carbonate. It does not end in IDE, so it must be on my list. Carbonate is CO3 with a -2 charge. Charges are not balanced, thank you. So I need to bring in another carbonate. Oops. So it's a -4 charge, and that goes on the outside of the parentheses. All right. Okay, for homework, I want you guys to do, starting with number 5 up here, 5, 6, 7, 8, 9, and 10. On the bottom, start with number 15 and down, and that's it. So that would be 11 problems. Just remember, you guys, I'm uploading these all to my wiki page. I sent you guys the link before so that you guys can check just in case you forget how to do these.